Hey there guys, and what's up? So in this video we're going to be talking about the top 10 data structures and algorithms used in interview questions. So if you prepare this list about algorithms, you'll be fine throughout your whole data interview. So this is given that most companies, not the top companies such as Google, especially for the software engineering positions, but it will cover about 80% of the top questions that you're going to be asking. So let's get to it. So in the post, top 10 coding questions and important topics and the solutions were written, we must talk about a lot of stuff. So we're going to be going through these problems, and going through these is a must. So the topics are graphs, linked lists, dynamic programming, and we have a lot of stuff like sorting and searching, binary tree, and we got number theory, and along with that we got bit manipulation, string array, etc. Next, let's talk about graphs. We have BFS, breadth of search, DFS, digesters, or the shortest path from the source to all vertices. That is also known as digesters. Then we have the shortest path from every vertex to the other vertex. That's Floyd-Marshalls. So you have to understand the difference between digester and Floyd-Marshall. Floyd-Marshall is actually each vertex to every other vertex. So we're going to get n into n. So because we have that's totally about n squared. So the overall complexity for this will be high, since we have to consider the iteration of each and every vertex to the other one. But for digesters, we only have to consider for the source to all the other vertices. That means 1 into n, that is n. Next, we also have to detect the cycle in a graph, or union find. Next, we have the minimum spanning tree, prims, and the minimum spanning tree of crucials, topological sort, boggle, and bridges in a graph. Then we are talking about a linked list. We have insertion of a node, deletion of a node, compared to strings represented by linked lists. Then we have add two numbers by linked list. We have merge a linked list to another one at different positions. It may be one at 0 or at the middle or some random number, or we're just adding two numbers at once using these add represented by linked lists. Then we have reverse a list in a group so given size. Then we're going to have a union and intersection of two linked lists. You basically know the union and intersection of two linked lists in this case. You're going to also reverse the list of several groups. We're going to have and detect a loop in a given linked list. We're going to merge sort for linked list. So merge sort is basically simple for this. We talked about this before. So select a random node from a single list. So these are all problems which we're going to cover actually throughout the whole series. So I hope you guys actually go through each of the videos to actually go and understand how they work, how the code is implemented, etc. Then we have dynamic programming. So we got long and common subsequence, the longest increasing subsequence. The common subsequence is basically the one which has the most repetitions. The increasing one is basically the one which has the highest increasing order, consecutively that is. We got the distance at a distance of the dynamic programming. We got minimum partition, ways to cover a distance here, and we got the longest path in a matrix, the subsequent sum problem, and we got the optimal strategy for a game. There's a game, it can be any game, it can be a random game, it can be a common game, which basically given to us by game theory in this case. We got a longest 0 to 1 knapsack problem. So knapsack is really fun actually. We got Boolean parenthesization problem. So these are good problems actually to get started with. Then we got sorting and searching. So we got binary search, bubble search, insertion, merge. Then we got heap, quick, interpolation, find the fifth smallest largest element in an assorted array. Then we're giving a sorted array and number x. Find the pair of the sum whose sum is closest or equal to x. So these are all good problems actually. Then we got tree and binary trees. So we got the minimum depth of the tree and the maximum path sum of a binary tree. So the path sum is basically the sum of all the paths which they're actually given by. And we have the minimum depth. We talked about minimum depth before as the depth being the minimum at the starting of the node. And we have check if any array can represent a pre-order transversal. We got pre-order, post-order, and in-order. So we also check whether the binary tree is a full or not. Is it half? Is it incomplete? Etc. So you also have the bottom view of a binary tree. So these are good problems actually. So we have the print nodes at the top. We got remove nodes on the route to leaf paths for less than k. And we have the lowest common ancestor. This is a very important problem, the lowest common ancestor. Then we have check if a binary tree is a subtree of another binary tree or not, if we're given two binary trees. Then we have a reverse alternate levels of perfect binary tree in this case. Then we got number theory. So number theory is pretty easy. It's about the basics. It has modular exponentiation, it has modular multiplicative inverse, it's got primality test or a Fermat method test in this case. Then we have Euler's totient function. We got Sieve-Ratissance. We also have the convex hull. This is extremely difficult and one of the NP incomplete problems. And we have the basic and extended Euclidean algorithms. We got segmented sieve. We got Chinese remainder theorem and Lucas theorem. So these are all good problems actually. I'm so excited just talking about these. We have bit manipulation. So in bit manipulation we have the maximum subarray XOR. Then we got the magic number. We have the sum of bit differences among the pairs. Then we got swap all odd and even bits. Along with that we got to find the element that appears once in this case. Along with that we have the binary representation of a given number. And we have, along with the binary representation, we have the count total set bits of numbers from 1 to n. And we got the rotate bits of a number. We got count number of bits to be flipped and convert to A to B. And we have the sparse number. So keep going, we have strings and arrays. So strings and arrays are basic. We have a reverse array. We got palindromic problems. We got triple sets. We got array into a zigzag fashion. This is something new and maybe you have not heard of that. It's kind of a trick question. Then we have all sorted arrays from alternate numbers of two given arrays.